Hey guys, I wanted to make a video about this problem because people ask me about this problem in office hours every single week. And so I have to explain this thing, and it takes me like 20 minutes every single week. And the thing about this problem is that it's not very important. I just don't care about it that much, okay? And the reason that I don't care about it that much is that you also shouldn't care about it. This question is just not that important. One thing you guys should be thinking about strategically is, how can I maximize the number of points gained on this test for the number of hours that I have for you to study, right? You guys don't have infinite time. You have a limited number of hours that you're gonna actually put into this thing before you get sick of it and finally take the test. And those hours should be spent as efficiently as possible. So this whole topic, I think that you should study topics that are what I would call a high value topic, okay? A high value topic is something that it's not going to take me that long to get good at, and it's going to get me lots of points. This is the opposite of that, okay? So this topic is what is called combinatorics. Combinatorics is just any topic where you're trying to find the number of ways to order something, or how many ways you could select a small group out of a big group. And this whole topic is pretty tough, and it's pretty hard to get a grip on it. And you don't even see that often. I feel like you could probably spend 20 hours on combinatorics before you got pretty awesome at it, or at least 10. And you're probably only going to see it like once on the test. And if you did, that would probably be the hardest problem on the whole test. So not that efficient, right? If you spent 10 to 20 hours, you might get 1 point out of this. Now contrast that with another topic, like I would say percents. Percents is it's a topic that I think you can get a handle on in maybe 3 hours, right? 3 or 4 hours of studying, you can get pretty awesome at percents. And percents are all over the place on this test. It will help you with 5 to 7 or 8 questions. So without studying that much, you could get better at 5 to 7 questions, let's say. So in terms of efficiency, studying percents is a much better use of your time than studying this whole topic, right? It'd be great if you did study this topic eventually, but this is kind of like your lowest priority. And that's kind of why I'm making a video, because as a teacher, I want to cover stuff that's more important in person. And this kind of thing, you can just watch my video, okay? Anyway, I guess I'll get into it. Oh, and by the way, I want to point out one piece of evidence that this is a tough problem. The paper-based GRE is not organized the way that the computer-based GRE is, okay? The computer-based GRE is, here's a whole bunch of questions, mixture of difficulties, they're all in random order, sort of. So question number 1, you have no idea how hard or easy it is. The paper-based GRE is different, okay? It starts off, the first question that you see in a question type is the easiest, and it generally gets harder and harder and harder until the last question in that question type is the hardest. So for example, in this test, the first 11 questions are multiple choice. Number 1 is the easiest. Number 11 is the hardest one. And guess what? This is the 11th one. This is the hardest one, the hardest multiple choice in this section. The next question is a fill-in-the-blank question, and the difficulty sort of resets there, okay? So this is pointing out that the GRE people themselves think that this is a pretty tough question, okay? And it's definitely the toughest one in this whole test, I think, because people ask me this every week. Anyway, no rage. Let's do this. So let's organize our thoughts a little bit. It says a reading list for a humanities course consists of 10 books, of which 4 are bios and the rest are novels. Cool. So let's take some notes. I'm supposed to read 4 bios, and then the rest are novels. Obviously what that means is, since there's 10 books, there must be 6 novels. Okay? Each student is required to read a selection of 4 books. Okay, so we only have to read 4 out of these 10 books, including 2 or more biographies. Now, the phrase 2 or more biographies, that's the part that makes this question really tough, okay? Because it's not just one scenario. If they had said, oh, you gotta read 2 bios, then I would say, oh, let's figure out how many ways there are to read 2 bios, and also how many ways there are to read 2 novels, and I'd be done. But since they say 2 or more, there's multiple ways to do what they ask, okay? So, how can we do what they want? Well, I'm gonna sort of color code this. One way of doing what they want is we could read 2 bios. If we read 2 bios though, we're gonna have to read 2 novels because we gotta read 4 books total. Cool, okay. What if, what 2 or more means more than 2, okay? So another option, instead of reading 2 bios, we could also read 3 bios. And if we read 3 bios, then we're gonna have to read 1 novel, right? The last option we have is we could just read only bios, because there are 4 bios, so I could just read 4 bios. And then how many novels would I have to read? Well, none, because I already read 4 books. So 0 novels. Each of these 3 scenarios would do what this professor is asking, right? In each of these 3 scenarios, I'm reading 4 books. It's just, it kind of depends on how many bios and novels we're reading. Cool? So what we're going to have to do is figure out how many different ways this first scenario could happen. When we're done with that, then we're going to figure out how many ways this scenario could happen. And when we're done with that, we figure this one out, and then we're going to add all 3 of these. Cool? This is why this problem kind of sucks. However, it's not as bad as it looks. This first part is the toughest part. After that, it gets significantly easier because I'm going to show you some tricks. Anyway, for this first part here, there isn't really a trick. There's just, here's how you do it. So I'm going to have to do a little bit of a lecture here, but when you are doing combinatorics problems, a lot of times a good way to look at it is to make a slot diagram. Okay? So let's look at just the 2 bios by themselves. This is actually sort of 2 questions. It's like, how many ways can you read 2 bios if you have 4 bios as options? That's 1 question. We're going to treat that all by itself. And then when we're done, we're going to look at the novels. Okay? So how would you do this 2 bios out of 4 bios question? I'm going to show you sort of the logic behind it, and then I'm going to show you the mathematical sort of formula, which is pretty simple. Okay? But let's just start with this. So one way of looking at it is, hey, I'm going to read 2 bios out of 4, and a slot diagram is a really helpful sort of tactic for many of these combinatorics problems. A slot diagram goes like this. I have 2 options. Okay? I have 2 choices to make. The first choice is, which bio am I going to read first? The second is, which bio will I read second? And then what you do is, you're going to put the number of options you have in the first slot, and then the number of options you have in the second slot. Okay? So for my first bio, how many options do I have? I have 4, because I can read any of them. Okay? Now for my second one, how many options do I have? This time I only have 3, because I'm not going to read the same book twice. Okay? So I only have 3 books left. Cool? Now, what does this mean? It means that when you're done with this, you want to multiply these 2 numbers. Okay? So this means there's 12 ways that I could read 2 bios. Cool? However, there's a slight flaw with this. Because if I read, say the first bio I read was Anna Karenina, and the second one is not really a bio, but whatever. The second one I read is the Brothers Karamazov, right? So that is one scenario that could have happened. But what if I read the Brothers Karamazov first, and then Anna Karenina second? That's really the same 2 books, right? So does the professor care what order you read these books? Doesn't really care. So if I read A first and B second, that's the same as if I had read B first and A second. So these 2 scenarios should not count as different scenarios. So what that means is I need to divide this number out by the number of ways there are to arrange 2 books. Okay? So 12, there's 12 ways that I can read 2 books if you care about what order you read them. But since I don't care about what order I read them, I'm going to divide that number by the number of ways you could have read them. Okay? The number of orders you could have read those 2 books. Long story short, the number of ways you can order 2 things is 2 factorial. If I was arranging, 4 paintings, the number of ways I could arrange 4 paintings is 4 factorial. Okay? Factorial is that little exclamation point thing, right? So 4 factorial, side note, 4 factorial is this. Looks like a 4 with an exclamation point. Okay? I pronounce it 4. Stupid. But anyway, what it means is 4 times 3 times 2 times 1, and that's 4 factorial. So this would be the number of ways you could arrange 4 things, right? But back to this problem, I'm really only arranging 2 things. So what I want to do is divide this number by 2 factorial, okay? Or really, that's just 2 times 1, which is just 2. Cool. So what I get is 12 divided by 2, and that's just 6. All right, so we're finally done figuring out how many ways we could read just the bios. It took forever, but mainly because I was explaining the concept. It'll be faster when we figure out how many ways could we read 2 novels, okay? So this is a separate problem. We're going to read 2 novels out of 6 novels, all right? So if I use my little slot diagram, I would say I still have 2 choices to make, all right? First novel, second novel. Now, how many options do I have for the first novel? Well, I have 6 available novels, and then the second one, I have 5 left, okay? So 6 times 5 is the total number of ways that you could read 2 novels, but again, we don't really care about the order. So what I'm going to do is I'm going to divide this by the number of ways I could have read those 2 novels. That's just 2 factorial, okay? So that's just 2 times 1, okay? So on the top, this winds up to be 30. On the bottom, that's just 2. So 30 divided by 2 winds up to be 15. All right, so we have figured out the number of ways there are to read 2 novels if you have 6 novels. So this is sort of the background behind how you do this, but there's a formula for this that you can just memorize, and I kind of think you should just memorize because it makes these things super fast. I do like to understand the concept because sometimes understanding the conceptual background behind it is really helpful for tough problems, but if they ever ask you, hey, how many ways are there to pick a small group out of a big group, it's nice to just know this formula, okay? The formula is pretty simple. So the way that I describe it is this. Say you're going to choose 5 motorcycles out of 12 motorcycles, right? Somebody's going to give you 5 motorcycles out of the 12 that he has, and they're all different motorcycles. So I don't care what order I chose them. All I care about is how many different groups of 5 motorcycles I can get. So long story short, here's what I would do. Formula is this. It's the total motorcycles divided by the stuff you picked factorial times the stuff you didn't pick factorial. Okay? So, looks a little complicated, it's not that bad. The number on the top is just a total, and the numbers on the bottom have to add up to the number on the top. So what did I say? I think I said 12 motorcycles. They're handing out 5 motorcycles. So the math on this would be, since there's 12 motorcycles total, I'm going to write the 12 factorial. Okay? Since they are handing out 5, then I'm going to pick 5 factorial, and I'm going to not pick the other 7. So that's 7 factorial. And then you should have to deal with the arithmetic of this, and that's essentially the answer. Now, the arithmetic on this looks kind of nasty, but it's not that bad. If you use a bit of a shortcut, I know the number on the top is 12 times 11 times 10 times 9 times 8, etc. And I can kind of see that this 7 is going to cancel out most of that. So I wouldn't even write all those numbers. If you deal with a lot of combinatorics, you can kind of shortcut this a little bit. So here's what I would probably write. I'm going to switch to black so you can see a little bit better. I would say, look, the 7, 6, 5, 4, 3, 2, 1 is going to cancel out the 7, 6, 5, 4, 3, 2, 1 for the 12. So I would write on the top 12, 11, 10, 9, 8. And then the 7, 6, 5, 4, 3, 2, 1, I don't have to write it because the 7 factorial is going to cancel that out. Now, let's deal with the 5 factorial. I would actually write 5, 4, 3, 2, and you don't really have to write 1 because who cares about it, right? So these numbers in the denominator should always cancel out with the ones in the numerator. If they don't cancel out, you did something weird, okay? They have to cancel out. Because if you're asking how many different groups of motorcycles there are, you're not going to get a fraction. That doesn't make any sense. So you need to say, oh, there's 62 groups. You can't say there's 1 52nd group. That doesn't make any sense. So these numbers in the denominator will always cancel with the ones on. Let's just cancel. I see 5 and 2 makes 10, so I'll just group them together. So they would cancel out to 10. I see the 4 and the 3 cancel out to make 12, right? 4 times 3 is 12. So then I just have to do what's 11 times 9 times 8, which isn't super easy, but that's just because I chose stupid numbers, okay? But you know what, now that I think about it, 11 times 9 is 99, 99 times 8 is pretty easy. You could just do 100 times 8, which is 800, subtract 8, which is 792, so not that bad. 792. Anyway, so I was just kind of trying to demonstrate the general technique, which is if you want to pick a small group out of a big group, essentially it's the big group on the top, factorial, and then the stuff you chose, factorial, on the bottom, times the stuff you didn't choose, factorial, on the bottom. Okay? Notice that those two numbers have to add up to the one on the top. 5 plus 7 is 12, because they have to cover all the stuff that you either chose or didn't choose. Anyway, I know I'm talking fast, but this is on YouTube, so you can pause anytime you want. So where the hell are we? We are midway through this problem. It looks like we barely started. We're actually almost done. Okay? So what we found out was there's 6 different groups, 6 different ways I can read 2 bios. Okay? We also found out that there's 15 different ways I can read 2 novels. Now this itself is its own slot diagram, right? Remember, the slot diagrams are essentially saying, you know what, I'm going to erase this stuff over here. Need some space. But a slot diagram is essentially saying, hey, I have 2 different decisions to make, right? In this case, my 2 decisions are which group of 2 bios and which group of 2 novels. So that's 2 slots. Okay? So my first slot is, how many different options do I have for the bios? Well, we figured that out. It's 6. So I would just write 6 up here. Okay? And then for my second, it's how many different ways could I read 2 novels? And we figured out earlier that there's 15 different ways that can happen. So I will write 15. Okay? So finally, we'll just multiply these 2 numbers. What's 6 times 15? Arithmetic trick. 6 times 10 is 60. And 5 is half of that, so that's another 30. So if you add that up, you get 90, right? 6 times 15 should be 90. All right. So finally, we figured out the scenario for this first scenario. Okay, these guys equal a total of 90. Let me put it right here. All right. So in the first scenario, there's 90 different ways to read 2 bios and 2 novels, but we haven't figured out these other ones yet. Don't be scared. It's actually going to be easy. But test sort of strategy. A lot of problems, if you're like sort of halfway through a problem and you've made some progress, you should always check answer choices. Okay, especially if I only have like 10 seconds left on the test. Check it out. If I look at the answer choices, I notice that the answer choices are 90 and then a bunch of numbers above 90. Okay, so what do we know? What we know is it's 90 plus some more stuff. So A says 90, and I know that it's not A for sure. Okay? Now I have no idea how many these options are, but at least I know right now that it's not A. And if I only had 10 seconds to spare, I could at least say anything but A. Cool? Alright, so let's get into the second scenario. So, second scenario basically is saying that you need 3 bios. You gotta read 3 out of 4 bios, and you gotta read 1 novel out of 6 novels. Okay? Now we could do the exact same formula for this, but I want to show you sort of a conceptual trick that's much faster. So let's say that you are hanging out with 11 of your friends. And you're like, hey, I want to take 10 of you guys out for drinks. So how many different groups of 10 of your friends, out of 11 of your friends, could you take out for drinks? Well, we could use this formula up here, but I think an easier way of looking at it is this, right? You're taking all of your friends but 1 to go out drinking. Not super cool of you. But one way of looking at it is, I'm not going to take, instead of saying, hey, how many ways can I select 10 out of 11 of you? Really, we're rejecting 1 person. So it's like, how many ways can you reject 1 person? How many ways am I going to make one of my friends feel bad? Okay? Well, I could reject that friend. That means I'm picking the other 10. Or I could reject that friend. That means I'm picking the other 10. Or, and essentially, there's 11 different ways you could make one of your friends feel bad and make the other 10 drunk, I guess, okay? So what I'm saying is, rather than doing this formula, if they ever ask you, hey, you need to pick all but one of something, you don't even need the formula, okay? It's just the number of things. So if we're gonna read 3 bios out of 4 bios, the shortcut is saying, hey, really, I'm deciding which bio do I not feel like reading, okay? And there's 4 different ways I could do that. I could say, not that bio, not that bio, not that bio, or not that bio, and that's 4. So no math required, cool? So if there are 4 ways that I could sort out the bio situation, let's look at the novel situation, okay? So how many ways are there to read one novel out of 6 novels? Well, that's pretty obvious, right? We could read one novel out of 6, it's 6 different ways. So I'm gonna write that in red, and then this is its own little slot diagram, because it's like, all right, if we're in the second scenario here, my first bios am I going to read? Okay. My second decision is which group of one novel am I going to read, and I'm just going to multiply these. This winds up to be 24. Okay. Put it over here. This is 24. All right. So we figured out the first scenario. It's 90. We figured out the second scenario. There's 24 ways we could do this second scenario. Let's look at the third scenario, which is actually stupidly simple, because it's saying how many ways are there to read 4 bios out of 4 bios? Well, there's only one. Right? There's only one way you can do this. So this is just one, not really any math required. Okay? You could use this big complicated formula for the second and third scenarios, but it's going to give you the same number that you can just sort of logic out. Cool? Alright, so we're nearly done with this. We figured out that in the first scenario there's 90 ways to do that. In the second there's 24 ways to do it. And then the third there's 1. So at this stage I actually sort of tried to line these up so we could add these in our heads pretty quickly. 90 plus look, this is 25, right? 24 plus 1 is 25. 90 plus 25 is 115. That is my answer. Cool? Anyway, if this whole lecture sort of went over your head, don't stress it. This topic sucks. It's not that important. I'd rather you were studying percents. Okay? Have a great day, everybody. Bye.